You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Tim O'Connor, Principal Process Engineer at KBR in South Australia, and we're discussing how to optimise performance to enable greater capacity. Welcome, Tim.
Thank you for having me.
Can you tell us a little bit about the brief that was presented to KBR by Melbourne Water when you first got involved in this project?
To me, when I first saw the brief, it was invigorating in one way to see how far Melbourne Water were willing to open up the review of their dissolved air flotation thickening process. And I use a jargon called DAF because it's just easier to say it. And that review looked at both technical and also management review aspects. So that was the first start of the brief, but also understanding the stakeholder project objectives. What do we want to achieve at the end of this whole process? And also, how could we quantify the improvement by like a number that we could easily say, yes, we've demonstrated that we've met our project objectives, rather than just a word.
It sounds like there was obviously a review of plant practices and systems there, but also potentially some operational or management practices as well. Is that what you were finding when you were given the opportunity to start this?
Correct. I suppose the first part was a massive amount of data to sort through. Their dissolved air flotation thickening plant has 9 individual tanks. And when I started looking at the data and its performance, we quickly understood that they had 9 individual plants, and for a plant operator, that's very hard to try and maintain that type of performance. That was probably one of the key findings, was to somehow consolidate all those 9 process units into one singular one.
And for those of us who are feeling a bit daft, which is DAFT, can you tell us a little bit about the DAF process, the DAF process, and why that's so important when it comes to improving, I guess, capacity and operational function?
The Eastern Treatment Plant operates with an activated sludge process, and every day it has to remove a certain quantity of solids or biomass. With that solids comes with water. So, and because the sludge then moves on to into the anaerobic digesters, which are just circular tanks with roofs on them, we try and thicken that sludge as best we possibly can to get rid of a lot of the water. And that water goes back into the treatment process to be retreated, and we capture and harvest the solids. So there are many different types of processes, but for Eastern Treatment Plant, it's a dissolved air flotation thickening process.
And you've been involved operationally with plants before. You've been involved in building them, is that right?
Correct, yes.
So has that helped you approach when you're coming to a project like this?
Yeah, because I kind of work through my own checklist. In doing so, you quickly troubleshoot a plant, and then that allows us to develop a hit list of things that need to be further investigated.
When you came back to Melbourne Water with some analysis of what you'd found, what was the next step? Were you looking at changing the design, or were you coming back with recommendations to change how operations were conducted? What was it looking like for you?
Part of that early investigations was that no singular tank was consistent in terms of how it was designed. There were some different practices that different designs that were developed historically and were trialled. What I was allowed to do was to identify all the design improvements and say, if we do all these, we'll get to our goal. It was encouraging for Melbourne Water to embrace those changes and were willing to invest the time and effort, even with their operations department, their planning department, to roll out those changes, admittedly only to one tank, to then put that one singular tank through a true performance test.
And that test then helps guide the next steps?
It not only guides the next steps, but it validates the design improvements. and it's a very simple test because it's all visual. You can look over into the
Quite
tank.
the vision. Quite the vision.
To me, that's my run-of-the-mill job.
Look, you're a lucky guy. So tell me about some of the challenges for someone like yourself who has worked within organisations that manage these plants, but also who now is a consultant. What are some of the biggest challenges and opportunities for you when you approach a project like this?
I probably assume nothing, and by that I mean, why not explore all potential problems that could be associated with that plant? But I find the most important aspect is building that rapport with my client, who is not necessarily one individual. It can be a range of individuals, all having vested interests in wanting to achieve the same outcome. And it's understanding all their requirements and willing or not dismissing any of their concerns and taking all that all on board.
And I guess sometimes it's about proving that what you actually say is going to happen, and that was the power of the test design. Is that
That
right?
was the power of the test, and the fact that I had built these plants before, provided data from those plants to validate that these processes with these design enhancements do actually work. Not drawing on any other, I suppose, reference textbooks, examples. It's purely from real engineering applications and my understanding of what the processes, the DAF process needs to do.
And so was the project a success in terms of achieving the goals that you set out to achieve?
It was. So all the project objectives were met, and in some cases even were surpassed. When we did the performance test on DAF Tank 1 against a controlled DAF tank, the performance test showed that we were able to increase the capacity by a further 45%. And like all engineers, we like to see where the tipping point is. Melbourne Water were quite happy to stress test that tank to find out where it actually did tip over. We were then able to increase its capacity by 200%, but we suffered a reduced float thickness performance. Not by a lot, but we did suffer a little bit. But it showed the capacity of these design changes and enhancements, how beneficial they were for the plant.
And any takeaways for anyone else wanting to do process improvement works in other organisations?
Understand what you've got, understand where the limitations are, set key project outcomes, and by that I mean just a few, not necessarily pages and pages. And bring everyone on the same journey.
Sounds like a pretty good plan. We've been talking to Tim O'Connor, the Principal Process Engineer at KBR in South Australia. Thanks so much for your time, Tim.
Thank you.